This is a challenging geometry question. We have a square like this. Then we have a point, which is exterior. And on the left side of the square like this. First, we draw a line of length 6, which connects this point to this vertex of the square. Then we draw this line of length 3, and then finally this line which connects with this vertex of length 5. Our job is to find the area of this square. So, can you find the area? Okay, let us label the side of the square as x. So the area of the square will be x square. Now consider this right triangle whose sides are p and q. Using our favorite right triangle theorem, we have p square plus q square equals 3 square or 9. Now consider this right triangle. This is p, this is x, and this is q. So we have p plus x whole square plus q square equals 5 square or 25. Finally, consider this right triangle. We have this as q, this as x, and this side is the same as p. So, we have p square plus q plus x whole square equals 6 square or 36. This way, we have 3 equations and 3 unknowns. Using them, we can solve for x. First, consider this equation. Expand this part of the equation. We get here p square plus q square, which is the same as 9. So, substitute it here. Now we will find the value of p in terms of x. Take 9 and x square on the right-hand side to make it like this, and then divide it by 2x. So far, so good. Now, consider this equation. Expand it, then substitute p square plus q square as 9, and then take 9 and x square on the right-hand side to make this, and then finally find the value of q in terms of x like this. Awesome! Lastly, we will take these expressions of p and q and then substitute them in this equation like this. Notice that the denominator will be the same as it will be 4x squared. So take it on the right-hand side. Now we need to solve this equation. But notice that, fortunately, we have all the x squared terms here, and if you remember, our goal is to find the area of the square, or x square. So, let us substitute r as x square in this equation to make it like this. Now, expand this equation and then collect the like terms to make it into a nice quadratic equation. Using our favorite quadratic formula, we get r equals this, and we end up with 2 possibilities. On simplifying, we get the value of r as 51.42 and another value as 9.58. Great! Now substitute back r as x squared here. Now recall that p was this value, right? But it is also the side length of this right triangle. Therefore, it has to be positive, which means x squared has to be less than 16, and thus we can discard this value, and we are left with x squared equals 9.58. This is our solution. Don't forget to put the square units. Before we go, can you tell me how many similar exterior points can exist such that these 3 lengths remain the same? Let me know your answer in the comments. So good!